Suppose you invest $130 a month for 7 years into an account earning 9% compounded monthly. After 7 years, you stop making payments and let the money just sit there and grow for 30 years. How much will you have at the end? So let's set up a timeline here. So we have, this is our start, this is our end, and for the first 7 years, this blue is going to be your 7 years. We're going to make deposits. I'm going to use my steps for the deposits of 130. That's my payment. So every month we put that into the bank, and then at the end of 7 years, we stop making payments and we have this lump sum just sitting here. We don't know what that is yet, when we need to figure that out in order to get the final answer. Now we're going to look at the 30 years. So this will be the 30 years. So we leave that lump sum in the bank, we stop making payments, and then we just let that grow to a bigger lump sum. This is what the question is asking us to find. What is the future value at the end of that 37 years? So we have to break this up into 2 parts. We have the first problem that's for 7 years, and then we have the second problem, which is going to give us our final answer for the 30 years. Now we have to break this up. We can't do this for 37 years and just be done, because halfway this person stops making payments. So we have a situation where we have payments for 7 years, and then we have just lump sums the last 30 years. And so that's a different animal. What we know is that he's making payments of 130. We can figure out what the total number of periods are. Since he's doing this monthly for 7 years, we're only looking at the first 7 years. Monthly for 7 years, that's going to be 84 periods. That's because it's 7 times 12. We know that our interest rate is 9%, and we know that our little n, how many times it's being compounded in just 1 year, would be 12. If you're using your TVM solver for this, then just remember that, just remember that this would be your big N, and this would be your PYCY. Also, if you're using technology to solve this, you have to remember to put a negative in front of the 130, because that money is leaving your person. If you're going to use a formula, then you don't need to put that negative in. So a couple more things to think about. If you're using the formula or GeoGebra, you have to change this 9% into a decimal. If you're using the TVM solver on your calculator, then you can just plug it in as 9% and not worry about putting it in as a decimal. If you're using the formula, you're going to want to use the savings plan formula. Because we're making payments over a certain period of time. And what we're solving for is the future value, or another way to put that is your accumulated balance. No matter which method you use, when you solve, you should get your future value is $15,135.50. So this right here, I'll actually label this. This is future value 1. That's this here, future value 1. It's the first one. So that's what we just solved for. But now we're going to look at the second part of the problem, where we're looking at the next 30 years. Now this is different because we're not making payments anymore. We just have this lump sum at the beginning of this 30 years, and we just let it sit there and grow to a bigger lump sum. And that will give us our future value 2, our second future value, which is what we want our final answer to be, which is what we're looking for. So we're going to approach it in a similar fashion, but if you're using your formula, this one, because you're dealing with lump sums and there's no payments in here, this is when you're going to use the compound formula. Let's write down all of our information. Our big N, or the total number of payments, in this case, would be 30 years, and we're doing it monthly for 30 years. So that's going to be 360. Our little n would be 12, because that's how many times you do this a year. And if you're using your TVM solver, that's your PYCY at the bottom. We know that we're still using the same account, so it's still going to be 9%. We don't have payments here, so I'm going to put in payment is 0. And then we're looking for our future value again, or the accumulated balance. So when you put that into your formula or GeoGebra or your TVM solver, your final answer will be $222,954.63. Now, there's a second part to this question. It says, suppose instead you didn't invest anything over the first 7 years, and then deposited $130 a month for 30 years into an account, earning 9% compounded monthly. So here's our new picture. We're not putting anything in the first 7 years. There's nothing. So we're just going to look at this in terms of 30 years. We're doing nothing over that first 7 years. So we're looking at 30 years. Now it says if you put $130 a month in for 30 years, what would you have at the end? So we're making these $130 payments, and we want to see what that end result would be. So we're looking for a future value. We're trying to save money, and we're doing it with making payments. So this would be, if you're using formula, savings plan. And let's go through and see what we have here. So our big N, or the total number of periods we would have here, is we're doing this monthly for 30 years. So that's going to be 360 periods. Our little n, which would be our PYCY if we're using the TVM solver, is 12. We're still doing this monthly. We don't start with any present value or principal. We're just going to start making payments of 130. Don't forget to put a negative in front of that if you're using technology. Oh, and we're still using the same bank account, so it's going to be 9% interest still. And then we want to solve for the future value again. We want to see what we have at the end if we just make payments for 30 years. Now, when you do that, you should get an answer of $237,996.65. When we compare this to the 37 years up here, notice we made more money by just doing payments of 130 over 30 years rather than starting with a lump sum that we have from 130 payments over 7 years and then letting that lump sum grow over a period of time.